All right. Good morning or afternoon, guys, depending on when you're listening to this. Obviously, today I am not here, so we are going to take a look at graphing parabolas in standard form. These are the same equations that we have been factoring all this time, and you're going to see how it looks on the graph. This lesson is really important. You're going to have a quiz in We'll go over some stuff next class period, and then the class period after that, we will have a quiz over this. So it's really important that since I'm not here, that you actually go through it and try to understand most of the vocabulary and see how these things work. All right, a quadratic function. A quadratic function is, a quadratic function that can be written in the standard form. So we're used to this form, ax squared plus bx plus c. Okay, so that's the form that we've been looking at. That's the form that we have been factoring and we're familiar with. So all quadratics are in the form ax squared plus bx plus c. If you see that it has a squared, okay, you see this squared up here. If x is squared, we know it's a quadratic function. All right. A parabola. Parabola is the shape that makes the quadratic. So this is the U-shaped graph of a quadratic function. It looks like a U, not a V. Make sure when you're graphing it, it doesn't look like a V, that it looks like a U. All right, the vertex. And you guys seen some of this vocabulary last year when we were looking at these parabolas. So the vertex is the highest or lowest point on a parabola. Okay, so this one over here, this point down here, that is the lowest point on the parabola. If a parabola looked like this, it would be the highest point for the vertex. Okay. Axis of symmetry. That's the vertical line, okay, that divides a parabola directly in half, so into two equal or symmetric parts. So we look over here. The axis of symmetry is the red line that goes down through the middle and cuts that parabola directly in half. Okay, so we know it's symmetrical, which makes it nice to graph. All right, domain is all the possible inputs or x values. We already know that. And the range is all the possible outputs or y values. Now we're going to see what the parent function looks like. Okay, I'm going to open up my Desmos graphing calculator. You guys can explore it as well. All right, and I'm going to put in the function f of x equals x squared. So I'm going to switch over here to my graphing calculator. And if you can see, I put in y equals x squared because y is the same as f of x, and the Desmos calculator prefers y. So if I look at my red graph right here, the red line, the red parabola, that is the parent function. That's the function that every parabola starts with because it's just x squared. Okay? But if I put a 2 in front of that x squared, if I put a 2 in front of that x squared, then I'm going to get the blue line. What happened from the red line to the blue line? Okay, it looks like the blue line got skinnier. Okay, the width of it changed. It got skinnier. Okay, it's like a rubber band. It gets skinnier the bigger the number. Okay. The higher you stretch it, the skinnier the rubber band gets. That's the same with this. The higher the number, the skinnier the rubber band. And then the green one, the green line, notice that it's a fraction in front of the x squared. Since we have a fraction in front of the x squared, it's going to release the rubber band some, okay, and the parabola is going to get wider. So notice that the green parabola is wider than the other two. Okay, so it's just like the rubber band. When you stretch it, The bigger the number, it stretches and the parabola gets skinnier. When it's a fraction, it releases the rubber band and the rubber band gets wider. Okay, so that's the same thing with parabolas. All right, so let's go back to our notes. For f of x equals x squared, okay, that is directly on 0, 0. So I'm going to do this in red because that's what it was. Okay, 0, 0 is where the vertex starts. Okay, so it's 0, 0. All right, and then I'm going to go back to the Desmos graphing calculator, and I'm going to plot those points on the graph. So I notice that my red one, my next point, exact points are 1, 1, and then the next one would be 2, 4. So I'm going to plot those points on the graph over here. So 1, 1. And because the other side is symmetrical, I'm going to plot it on the other side too. And then 2, 4. And 2, 4. Negative 2, 4. Okay, and then I can draw my parabola. So that is the parent function. And we're going to look at all of the different vocabulary that goes with that parent function. So where is the axis of symmetry? It's directly in the middle. So that means when x equals 0. There's your axis of symmetry. It goes right through the middle when x is 0. Axis of symmetry is always x equals. Okay, because it's a vertical line. Remember, vertical lines always have x equals equations. Okay, domain for these is simple because they're always going to be all real numbers. Or ARN. Okay, so the domain is always, it doesn't matter what kind of parabola it is, the domain is always all real numbers because it's going to continue to go in either direction. Those arrows are going to keep going up and go out as far as they can. Now the range is a little bit different. Okay, let's look at where the graph is. If the graph opens up, okay, if the graph opens up, that means that the parabola is going to be above the vertex, okay, above the y value. So for this one, we're going to say that y is greater than or equal to 0. Okay, it's whatever the y value of the vertex is, so the y value is 0. And it opens up, so it's above the vertex. It's going to be y is greater than or equal to 0. The a value also tells us if the function is a vertical shrink or stretch. A stretch is when a is greater than 1. And a shrink is when a is between 0 and 1. Notice they're both positive. Okay, 1 is greater than 1, and the shrink is between 0 and 1, so there's not any negatives in the shrink or stretch. Now, if it's between 0 and 1, that means it's going to be some type of fraction or decimal. Okay, it's going to be a really small number. So let's look up here. We have our parent function, f of x equals x squared. But then I showed you what the graph would look like if it had a 2 in front. Since there's a 2, this 2 tells me that that is going to be a stretch because it's greater than 1. Okay? And then this one is a fraction. So the a value is a fraction. That's going to tell me that that is a shrink. Okay, so this is a shrink by 1/2, and this is a stretch by 2. Okay, and then you could see those on the graph when we did the Desmos graphing calculator. You can see the shrink and the stretch, and we talked about those already. All right, how do these graphs change from the parent function? Okay, so if we look here, the y-intercept is always the c value. Okay, in this case, there's no b term. Okay, 5 is the c value, and this is the a value, ax squared, which is just 1. And so the y-intercept is always the c, okay? And that shifts the graph up or down. So the y-intercept in this case is 0, 5. It's always the c value. The y-intercept is always the c value. All right, number 2, in this case, we don't have a y-intercept because it would be plus 0. So the y-intercept is going to be 0, 0. And if we look at the b term is what shifts the graph left or right, okay? And the b term has an x, okay? The b term has the x. The c term is the constant, and the constant is the y-intercept, okay? Know these vocabulary words. We're going to practice them a lot, and we're going to be using them. We have to define them as we are working on these. All right, the x-coordinate of the vertex. So we're going to be graphing ax squared plus bx plus c. The x-coordinate of the vertex is the axis of symmetry. We talked about that above. X equals. Okay, and then once you find the axis of symmetry to find the y-coordinate, you have to plug it back into the equation. Okay, so the axis of symmetry, here's the formula you have to have memorized. X equals negative b over 2a. Okay, all right, once we have that, we're going to just give you some vocabulary here and some equations, formulas, and then we're going to learn how to graph those. Okay, a parabola opens up if a is positive and opens down if a is negative. Okay, so a parabola opens up like this if a is positive. It opens down like this one if a is negative. It flips it over. We call that a reflection. Okay. All right. Parabolas that open up will have a minimum value. So this one opens up. This one is a minimum. Okay. And this one opens down. That has a maximum value. And when we talked about a little bit earlier when we were doing the parent function, x squared, the range, if it's a maximum, the range is going to be y is less than or equal to 0, or whatever the y value is. Okay, so it's not always 0, it's whatever the y value is of the vertex. And the max or the minimum, when it opens up, it's always going to be y is greater than 0, or whatever the y value is. Okay, so it's not always 0, it's whatever that y value is. Okay, the value of c is the y-intercept, and again, a lot of these are going to be repeated because it's really important to remember these vocabularies. And the value of b shifts the graph left or right. Okay, so that's some of the important vocabulary. Now we're going to kind of put it into practice. All right, example 1. We have to state if the quadratic function below would open up or down. Is it a max or min? What's the max and min value? Then find the axis of symmetry and the vertex. Okay, so let's start with the axis of symmetry because that's the first thing we need to find the vertex. So the axis of symmetry, the formula for that is x equals negative b over 2a. I'm going to label my parts up here. This is A is 2, B is 8, C is negative 1. Okay. Right off the bat, actually, let's go down here. I know C is negative 1, so that is my y-intercept. That's my constant. So I can go down here to the y-intercept, and I can fill that in as 0, negative 1. We know that's the y-intercept. It's always the C value. Okay. All right, back to the axis of symmetry. I need negative, and my B value is 8, so negative 8 over 2, and then my A value is times 2. Okay, then I have negative 8 over 4. Negative 8 over 4 is negative 2. Okay, so that means the axis of symmetry is x equals negative 2. You have to write the x equals. Okay, because we have x's and y's, and we don't want to get those confused. So you have to write what the variable is in this case. You cannot just write negative 2. All right, so x equals negative 2. Now that I know x is negative 2, I'm going to take that negative 2, and I need to plug it into every x value and solve it. Okay, so I'm going to put it just down here. I have 2 times negative 2 squared plus 8 times negative 2 minus 1. All I did was plug it in for all of the x values exactly the way it shows. All right, negative 2 squared, negative 2 times negative 2 is 4. And then I have 2 times 4, which is 8, so I'm going to have it 8. Plus 8 times negative 2 is negative 16 minus 1. Okay, so 8 minus 16 minus 1, I need to add all of those up. And when I do, I get negative 9. So my vertex is the x value of the vertex is negative 2. That's the axis of symmetry. And the y value we just solved for is negative 9. Yes, this is work. It's easy work, but it is a lot of work. So you got to be able to do all of that math. Use your calculators and plug stuff in, and you should be just fine. All right, now we have max or min value. If I look at my A value, okay, this is my A value is 2. Is 2 greater than 1? Yes, since 2 is greater than 1, it's going to be a max. Okay? Or no, sorry, I just did that wrong. Since 2 is positive, sorry, if 2 is positive, then it's going to be a max or a min. Okay, so in this one, 2 is positive. This one is going to be a minimum because it's going to open up. Okay, hopefully I didn't just confuse you as I said all that stuff wrong. Okay, so it's a minimum because A is positive, it opens up. So this one is going to open up. All right, and then the minimum value is always the y value of the vertex. Y equals negative 9. Okay. All right, now we're going to go to the domain. The domain is always the same, all real numbers. Okay. Every one of those parabolas is always going to be all real numbers. Now the range, because it opens up and A is positive, it's going to be the y value of the vertex, but it's greater than or equal to negative 9. Okay, so see, it's not 0 in this case, it's negative 9 because that's the y value of the vertex. All right, we already got the y-intercept. Now the shrink or stretch. That's what I was thinking of earlier. Is this a shrink or is it a stretch? Since the A value is greater than 1, it is 2, that is going to make it a stretch by 2. All right, so that is all the vocabulary that we need to figure out just by looking at the quadratic function. Okay, so we're going to try it again on the other side, number 2. We have f of x equals negative 1/3 x squared plus 6x plus 5. Okay, we need to find the axis of symmetry. You need to have memorized that formula, x equals negative b over 2a. All right, so this is A, this is B, this is C. So negative 6 over 2 times negative 1/3. On the bottom, 2 times negative 1/3 is negative 2/3. Okay. Now, if I divide those, this looks like this. Negative 6 divided by negative 2/3. Can I divide a fraction? No, so I'm going to have to change it. Negative 6 times negative 3 over 2. And I can put the 6 over 1. So in that case, what does that give me? So negative 6 times negative 3 is positive 18 over 2. And 18 over 2 is just 9. So the axis of symmetry is x equals 9. Now I need to take that 9 and plug it into all of the x's up here. And when I do that, I'm going to have negative 1/3 times 9 squared plus 6 times 9 plus 5. Okay? And when you do that, you have 9 squared is 81. You can divide that by negative 3 plus 54 plus 5. So if you do all the math for that, that's going to equal 32. Okay, so the y value is 32. So our vertex is going to be 9, 32. Okay. Now, is this a maximum or a minimum? Okay, because it's negative, this value right here is negative. That means it's going to open down, and that is going to be a maximum. And the y value of the vertex is 32, and so it's going to be y equals 32. The max value is y equals 32. That means that's your high point. The domain is always all real numbers. The range, because it opens down, and this is negative, okay, it's going to be y is less than or equal to 32. The y-intercept is still the c value. The c value is 5, so it's going to be 0, 5. And the a value, we're not looking at the negative, we're just looking at this a value right here of 1/3. Since it's a fraction, it's between 0 and 1. That is a shrink by 1/3, not the negative. The negative only tells me if it's a max or min. The shrink or stretch is just the a value, the positive a value. Okay, so it's like the absolute a value. It's the positive a value only. All right, so now we got through all that vocabulary. We're going to practice graphing a couple of these. Okay, all right, so the first one, number 1. Negative x squared plus 2x plus 3. The first thing we have to do is go ahead and fill in all the bottom stuff just like we did top before we can start graphing. Okay, we have to have the vertex before we can graph. So we have the axis of symmetry. We're going to do x equals negative b over 2a. So this is my a, this is my b, and this is my c. Negative b is negative 2 over 2 times negative 1. A is negative 1. So negative 2 over negative 2 is positive 1. So the axis of symmetry is x equals 1. The vertex, I'm going to plug 1 back into my formula. So negative 1 squared plus 2 times 1 plus 3. Negative 1 squared is just 1, and that's negative 1 plus 2 plus 3. So my vertex, my y value of my vertex is 4. So my vertex is 1, 4. Okay, it's a negative, okay, and the max or min is negative, so that means it's going to open down. So this is going to open down. That means it's going to have a max. of y equals 4, which is the y value of the vertex. Domain, as always, all real numbers. The range, because it opens down, it's going to be y is less than or equal to 4. The y-intercept is the c value, so 0, 3. And it is a shrink or stretch. In this case, because the value is 1, the a value is 1, this is none. It's not going to shrink or stretch. Okay, it's just a reflection of the parent function. So it's just going to turn down, and the parent function does not have a shrink or stretch, only if there's a number in the front besides 1. Okay, now we're going to take our vertex. This is what's important. That vertex has to go in the middle of the table. So we're going to put 1 and 4 right in the middle of that table. And we are going to number our graph. Okay, we're going to number those from the vertex. So my x values are going to go in order. I'm going to do 2 and 3 at the bottom, and I'm going to do 0 and -1. So the x values are going to be -1, 0, 1, 2, 3. The x values are based off of the x value of the vertex. We number them in order from the vertex. Now the y values we have to plug in to find the rest of the table, okay? So I'm going to start with 0 because I know this is special. If x is 0, that means that's my c value. That's the y-intercept, okay? If x is 0, that's the y-intercept. Now because this is a parabola, if the x value is 0, that means this one, because it's symmetric, is also 3. Okay, now I'm going to choose to either do -1 or 3 because they're both going to be the same number. I'm going to plug -1 into the function. So I have a negative, and I'm going to just do my math right here. So -1 plus 2 times -1 plus 3. So negative times -1 squared is just 1, and times the -1 on the outside is -1 minus 2 plus 3. So -1 minus 2 plus 3 just gives me 0. So that means -1 is 0 and 3 is also 0. All right, so we are going to graph it now. So my vertex is 1, 4. So this is 1, 4, 0, 3, and my other point is 2, 3, and -1, 0, and 3, 0. Okay, if it does not make a parabola, you did something wrong. So this is a parabola opening down, and that's it. All right. I'm going to leave you guys to finish the rest of those. You can do your homework, okay? The only thing with this one down here is this is going to have a -3 up front. Since it has a 3, this is going to be a stretch by 3. Okay, the rest of it, see what you can do with the graphs, fill all of that in, and follow what I did up above on that. All right, guys, that is it for today. Make sure you get your homework done. Again, this is important. We are going to have a quiz in 2 blocks from now, so all of this vocabulary you need to know for next class. All right, have a great day. I'll see you next block.